Hey everyone, so welcome back to my channel, and without further ado, let's get started with today's problem. So the question for this video is: a string is tied to a 4.4 kilogram block and a 120 gram hanging bucket. Students add 20 gram washers one at a time to the bucket. The students are unaware that the coefficient of static friction for the block on the table is 0.42. So part A of the question asks, what is the maximum force of static friction for the block? And then part B, how many washers can the students add to the bucket without moving the block? So this is a very standard dynamics problem. Obviously, it's a physics problem. So let's start by kind of like analyzing the question. What is the given information? So obviously, we know that the block has a mass of 4.4 kilograms. I was actually going to say weighs 4.4 kilograms, but that would be totally wrong. So we're going to say has a mass of 4.4 kilograms. The bucket has a mass of 120 grams, and students add washers that have a mass of 20 grams each. Now, if you don't know what a washer is, that's not a big deal. You don't need to freak out about that. That's not even part of the question. Just it's something the students add to the bucket. So a washer is essentially it's like a round metal kind of screw kind of thing. So whatever. Anyways, I digress. Another piece of given information is that the block on the table has a static coefficient of 0.42. So the way I like to approach these kind of problems is that I like to draw a diagram. Like, you know, it doesn't have we're not going to start off with a free body diagram at first, just a basic simple sketch to kind of show you to kind of get you started on like what the problem actually looks like. So let's start off with the, it's nothing too fancy. If you're not good at art like me, just sketch it out. There's obviously there's a box on a table, just pretend it's sitting on a table. It's connected to, not from there. It's connected to a bucket, and I'm gonna say it's kind of connected like through a pulley system. So, and then I'm gonna draw like a bucket out at the bottom here. It's a really ugly bucket, but again, that's not the point. So there we go. We have a block. We know the mass of the block is 4.4 kilograms. We also know the mass of the bucket is 120 kilograms. Not kilograms. I'm sorry, grams. And this right here is kind of like your pulley. Okay, so this is kind of like your rough sketch. So after this, we can actually start drawing our free body diagram for part A of the question. So part A essentially is asking for what is the maximum force of static friction for the block. So if you've forgotten, let's go have a look at the question once again. This is really easy. It's like basically no calculations involved here. So draw out your free body diagram. So in this case, we're just drawing the block. So your block, there you have it. It's always don't forget to write the mass in the middle, just so you remember. And now you have to draw the forces acting upon it. So we know obviously it's sitting still. It has a normal force, right? And similarly has an equal downward force of gravity. So label those. I'm going to label those for you. So this is your normal force. So F subscript n with a little vector on top. And this is F subscript little g, so your force of gravity. So that's it. That's your free body diagram right there. I mean, it's really simple, but it's kind of needed for the problem. So make sure you draw the correct free body diagram. So your next step essentially would be to calculate. What can you calculate? You don't actually know what the normal force is, but you can calculate this for the force of gravity, because you know that the mass of the block is 4.4 kilograms. You know what the acceleration due to gravity is. It's always 9.8 meters per second squared. So there you have it. Also, you know that the box is still, it's not moving. Therefore, these two forces are in opposite directions, but of equal magnitude, right? So they kind of cancel each other out, so therefore the box doesn't move. So in terms of physics, we can write this out like this. We can be like the force of gravity, the normal force is equal to the negative of the force of gravity. I put this negative sign here just to indicate that they're in opposite directions, but the equal signs actually shows me that in magnitude they're the same. So when we simplify this out, we know that Fg is this, right? You can put the negative sign in, obviously just put it in because you'll see why. So mass 4.4 kilograms, and your acceleration due to gravity. Now the acceleration due to gravity is in your downward direction, right? So it's obviously like going down at 9.8 meters per second squared, right? So I would put in a negative sign because it's all to do with vectors and directions, so make sure you have your negative signs in the right place. And I really should have a negative sign over here. So once you put this into a calculator, you obviously see that the negative here and the negative here cancel out, so you should get a positive answer. And what I get is 43.12 newtons. And since it's a positive answer, the direction is obviously going up. So this is your normal force, right? You have your normal force now. So are we done with part A of the question? Not so much. I mean, we have a little bit more work to do. The question is actually asking us the maximum force of static friction, not the normal force. But obviously, in order to find the force of static friction, we're going to need the normal force, because I know you guys all remember this formula. The force of static friction, so F sub S, is mu sub S, and mu sub S is basically your coefficient of static friction. So mu is the notation, or is the symbol we use in physics to describe, especially in the dynamics unit, to describe the coefficients of friction. So mu sub S just means that it's the coefficient of static friction, so that's what the S symbolizes. And mu sub S times your normal force. So there you go, that's where the normal force is coming into play. And this is really easy. All quantities are given here, right? So we know from the question that this is 0.42. Now, you'll notice there's no units on coefficients of friction. They're unitless, they're dimensionless, whatever you want to call them. They're just numbers, so don't worry about a unit. But our normal force, which is 43.12, does have a unit. It's newtons, so please plug that in. You know, don't just ignore it. So this gives me 18 newtons, and that is your answer. So your force, maximum force of static friction for the block is 18 newtons. So you can just put a little therefore there, and if you want to write like an entire statement, I won't go through that, but obviously write that in. So that's part A of the question done right there. So now that that's out of the way, let's go have a look at part B. Part B can be a little bit complicated, so we're gonna go through it fairly slowly. Part B is asking how many washers can the students add to the bucket without moving the block. So we don't want to move the block. The block has to be still. Yet we're still adding on a certain weight or mass to the bucket. So for part B, I'm just going to make that bigger. So for part B, I would start off essentially by listing any givens I have. So what do we know? I know that the weight of the bucket, I can calculate that, right? Because I have pretty much a lot of given information. So the weight of the bucket, we can go solve for that. We know that it has a mass of 120 grams. We drew that out in our diagram over here, 120 grams. But I'm not going to use grams because all these problems use obviously kilograms. So that's really easy, you know, just convert your grams into kilograms. So the weight, so you know weight equals mg, right? So this is going to equal the mass of the bucket, so it would be 0.12 kilograms, and then obviously 9.8 is the gravitational acceleration, meters per second squared. And it's a little off the page, so ignore that. So that's that, and that should give you an answer of 1.176 newtons. Always carry on a few extra decimal places, just so you can, you know, kind of accurately round off your final answer. So just carry on a few extra decimal places throughout your problem. Don't start rounding from like the first part of the problem. So this is what I get. And this is essentially coming from the formula that weight is basically equal to Fg, right? So that is what weight is, which is basically equal to mg. So just in case you've forgotten, this is where I'm getting it from. Since, and I'm just going to write this out so we're all on the same page. Since 1.176 newtons is clearly, I mean, it's clearly less than 18 newtons. We calculated this. This is the force of static friction, and this is the maximum force, right? So this is the force of static friction, and obviously 1.176 newtons is obviously less than this. The box is, I'm going to write obviously, not moving. So, but we have a leeway. We can add more weight to the bucket, and the box still won't move. We only have 1.176 newtons pulling on the box, whereas we can have up to 18 newtons pulling on the box without it moving. So how much more do we need? We essentially need 18 newtons minus 1.176 newtons of force to basically, you could say, equal the maximum static force of friction. If I can spell today, oops, force of friction. There we go. Force of friction. So that's how much we need, right? Also, another piece of given information, we know that one washer has a mass of 20 grams, right? 20 grams, and we're going to write that again in kilograms because we're always dealing with kilograms in these kind of problems. So 0.02 kilograms, right? We can find out the weight of one washer, right? So the weight of one washer is equal to mg. That's your basic weight formula, right? So I'm just going to write that out. You can do a quick calculation. You can probably plug that into your calculator before me. So the mass is 0.02. Actually, you know, it's a little too big. So the mass, 0.02 kilograms. Again, acceleration due to gravity is 9.8 meters per second squared, and this gives you 0.196 newtons, right? So this is the mass of one washer. Here I should actually, you know, write it out. So 18 newtons minus 1.176 newtons is 16.824 newtons. So we kind of like need 16.824 newtons more of force, and the box still wouldn't move because we can basically have up to 18 newtons of force kind of pulling on the box, if you will, and the box will still stay still. So this is the information we have up to this point. The question is asking us how many washers we can add. So we need washers that are going to amount to 16.824 newtons. That's how many washers we need. And I'm going to continue this in the second part of the video because I'm running out of time.